In the following lecture, students will learn to balance redox reactions in both acidic and basic conditions. So let's go ahead and let's look at the balancing of redox reactions. So remember that when we're balancing redox reactions, we're not only balancing the number of each atom type, we're also considering the balancing of the number of electrons that have been transferred between your oxidizing agent and reducing agent. So let's say you're given an example, like the oxidation of iron plus 2 to plus 3 by dichromacy. Redox reactions are going to be involving both the balancing of atom types, just like you would with normal balancing, to follow the law of conservation of mass, but also the correct balancing of the electrons that are being transferred. Okay, so there's kind of two parts that are involved in redox balancing. Instead of just a singular focus like the regular balancing that you guys have done in the past. So in the context of redox balancing, we have acidic and basic situations that can potentially exist. Those will be indicated to you. And really all you need to do is understand that you're going to follow all of the same steps in acidic balancing as you will for basic balancing, but basic balancing requires an additional step, and we'll look at that at the end of these steps that we're going to look at here. So we've been told that we have a redox reaction right here, and that it's in acidic solution. Okay, so the first step that we're going to follow is the writing of the two half reactions. So obviously we want to identify our oxidation and our reduction. Okay, and we do that by looking at our oxidation numbers. Notice the iron has a +2 oxidation number because the charge of the ion is +2. +3 over here because it's +3 on the product side. Okay, so we know that's an oxidation process. If we go ahead and take a look at the chromium in this compound here, okay, our chromium is going to have a +6 oxidation state, as a +3 oxidation state here. Okay, and that is an example of the reduction process. So what we do is we write simple half reactions, okay, in this step. Okay, so notice guys, unlike the writing of the half reactions when all I'm asking for is just half reaction, in the context of redox balancing, the only thing you write is the species that are the reactants and products for the oxidation and reduction step. You don't include any electrons, you don't worry about that yet. That'll come up in later steps. So we've identified our oxidation reduction half reactions, and that's going to bring us to step number 2. In step number 2, you're going to balance any atoms other than oxygen or hydrogen that are in each half reaction. So in the example of the oxidation step, we don't need to worry about that at all because there aren't any other atoms than iron. Okay, in the reduction step, however, we have chromiums that we need to consider. Okay, so chromium here, there's 2 of them. On this right-hand side, there's only 1 of them. So when we go to balance this half reaction, we're going to put a 2 in front of the chromium on the product side. Now we have balanced our chromium atoms, which is the only other option other than the oxygen or hydrogen. Now in step number 3, we're going to go ahead and we are going to balance oxygen and hydrogen atoms. And we're going to do that by the addition of H2O and H+. H2O is added in order to balance oxygen atoms, and H+ is added in order to balance hydrogen atoms. Okay, so we're going to do that to each side, or to each half reaction, excuse me. Okay, so in this situation, we have 7 oxygens on the left-hand side, so we need 7 oxygens on the right-hand side, so we add 7 H2Os. Okay, over here, we're going to take care of our hydrogen atoms. Now that we've added 7 H2Os, we now have 14 hydrogens. 14 hydrogens on the right, so in order to balance that, we add 14 H pluses on the left. Okay, so now that we've balanced our hydrogens and our oxygens, that's going to bring us to step number 4. Now, I do want to point out, guys, that we don't need to do steps 2 or 3 on the oxidation step because there's no need to balance any other atoms, and there's no need to balance oxygen or hydrogen because there's none present in the reaction step. So our next step is to add electrons to each side of the half reaction. That's going to allow us to balance the charges of each half reaction. So what do I mean by that? I mean that the charges on the left need to add up to the charges on the right. So basically they have to be the same. So if I have +2 on this side and I have +3 coming from that Fe+3 ion, I need to make this side be +2. The reason why is because the only way I'm going to make these changes is by the addition of electrons. Okay, so I'm going to add 1 electron because 3 positives plus 1 negative give me an overall surplus of +2. Okay, and that matches with what's on the left-hand side. Okay, in that same vein, down here, notice I have 2 chromiums with a +3 charge, so I have a total of +6 on this right-hand side. Okay, so on the left-hand side, I also need to have +6. So if we go ahead and we look at what we have, okay, we have 14 H pluses, okay, and then we have a single 2- ion here, okay, so that's going to give us 12 plus from these 2 species. Okay, so we add 6 electrons to balance that 12H plus, and that gives us 6 plus on this side. Okay, so 6 plus on this side, 6 plus on this side. We have now added the appropriate number of electrons to balance the charges of each half reaction. Now we need to get the now we need to get the number of electrons in both half reactions to match each other. Okay, so that's step number 5. Notice I have 1 electron here and 6 electrons here. The reality of it is in redox processes, electrons have to be transferred in equal share. So basically, if I'm giving away 3 electrons, something needs to be accepting 3 electrons. It can't take a fraction of the electrons that are being given away. Okay, so in order to get these electron values to balance out, we need to multiply 1 or 2 or none of the half reactions in order to get that to happen. So in this case, I have 1 electron here, I have 6 electrons here. So what I'm going to do is I'm going to multiply this half reaction by 6. And I'm not just going to multiply the number of electrons, I'm going to multiply all of the substances that are in that reaction. Why? Because each one of these Fe2 pluses is giving away 1 electron. Okay, so I need 6 of them in order to give away a total of 6 electrons. Okay, so once I've done that, I check, okay, my number of electrons match. So I'm done with step number 5. Now, there may be situations where you need to multiply both of them, okay, or sometimes you won't have to multiply any of them, but in this case, it was only the one that we had to do. Our next step is we are going to take our 2 half reactions, and we are going to basically sum the 2 equations, and we are going to cancel out any species that show up on opposite sides of the arrows. Okay, so basically everything that's on the left-hand side will be brought down and put on the left-hand side of the arrow. Everything that's on the right-hand side will be on the right-hand side. Okay, so let's go ahead and let's do that. We have 6 Fe2 plus. We're going to bring that down. Okay, and then we have 6 electrons. And then we have 14 H pluses. And then we have 1 of our Cr2O72 minus ions. Okay, those are all going to be brought down on the left-hand side. And on the right-hand side, we're going to have 6 Fe3 plus 6 electrons, plus 2 Cr3 plus ions, plus 7 H2O. Okay, so now that we've brought all of those down, we're going to go ahead and look and see if there are any items that we can cancel on both sides. Okay, so first of all, electrons, 6 electrons and 6 electrons, those should be one of the first things that cancel out. Okay, now are there any other species that are the same on both sides? Okay, so I have Fe2 plus on the left, Fe3 plus on the right, those don't cancel each other. I have H plus on the left, I don't have any H plus on the right, those aren't going to cancel. Cr2O72 minus, this ion here, I don't have it on the left, or I have it on the left, but I don't have it on the right. Okay, so basically guys, this is the equation that you would end up with after you have summed those 2. So if we go ahead and we rewrite that, okay, we end up with 6 Fe2 plus 14 H plus Cr2O72 minus. And that gives us 6 Fe3 plus 2 Cr3 plus. And let's say plus 7 H2O. Okay, so now that we've written out the equation for this redox process, we want to go ahead and verify that the number of atoms and the charges are balanced on each side. Okay, so when we go through this process, let's go ahead and just look at the number of atoms. Okay, I have 6 FEs, 14 hydrogens, 7 times 2 is 14 hydrogens, 2 chromiums, 7 oxygens, 7 oxygens. So I have the correct number of atoms on each side of the arrow. The next thing though I need to check, remember, because this is a redox reaction, I have to check that the charges balance. Okay, so on this left hand side, okay, I have 6 times 2, which is 12 plus, okay, and then I have 14H plus. I have a single 2 minus charge, okay, so 14 times 1 minus 2, that gives me plus 12. Plus 6 times 2 is going to give me another plus 12, so that gives me plus 24. If we go ahead on this right hand side, 6 times 3 plus, that's going to give me 18. Plus 2 times 3 plus, that gives me 6, so that's 24. Okay, notice there is no charge on the H2O molecule, so there's no consideration there. So the number of atoms as well as the number or the charges on both sides balance each other. So we know that we have properly balanced this equation for this redox process. Okay, now some of you may be asking, okay, well, what about if this was in basic situation or basic conditions? The reality of it is you would do all of the steps that you've done so far, okay, except for the fact that you are going to add hydroxide ions to both sides for every H plus that appears in the final equation. Okay, so let's go ahead and let's look at this situation. Okay, so this is the acidic balancing. Now, if I would have told you that this was basic, in basic conditions, we would just take this equation and add step number 8. Okay, so I need to add hydroxide ions to both sides of the equation, and I need to add the number of hydroxide ions that counterbalance the H pluses that are present. So in this context, I'm going to add 14 hydroxides because I have 14 H plus ions. So 14 OH minus to one side, 14 OH minus to the other side. Okay, and then what we're going to do, guys, we're going to combine any H pluses with hydroxide, and that will give us water, right? Okay, so if I go ahead and I'm going to take this equation and I'm going to write it down here. Okay, so 14 OH and 14 H plus, that's going to give us 14 H2O. Okay, we're going to bring down all the other species. Okay, make sure that you're writing your charges. Okay, that gives us 6 Fe3 plus, plus 2 Cr3 plus, plus 7 H2O, plus 14 OH minus. Okay, so once we've done the addition of the hydroxide ion and basically then the reduction of the hydroxide and H pluses to give us H2O, we're then going to simplify. Okay, so H2O and H2O show up on both sides of the arrow. So in this context, what we're going to do is we're going to cancel out the H2Os that we can. So if I have 7 over here and 14 over here, that's going to give me a surplus of 7 here. So what I'm going to go ahead and do is I'm going to erase my H2Os here, okay, and I'm going to add or rewrite the remainder after that cancellation has occurred, okay. And then once I've done that, guys, I'm going to recheck my final answer, okay, using step number 7. Okay, so I have 14 H pluses here, okay, or 14 hydrogens here, 14 hydrogens here. Okay, I have 7 and 7 oxygens, so that's 14 oxygens. I have 14 oxygens here. 6 irons, 6 irons. 2 chromiums, 2 chromiums. Okay, and then of course I'm going to check my charges, just like I did in the last slide. Okay, so 6 times 2 is 12, minus 2 gives me plus 10. Okay, and then over here, if I do go ahead and check on the right hand side, I have 6 and 3 is 18, plus another 6 is 24, so plus 24. Plus negative 14 is going to give me plus 10 on the right hand side. So I have now balanced this equation here in basic conditions. So redox balancing, you follow all of the steps basically 1 through 7, regardless of if you are dealing with acidic or basic conditions. But in the context of basic conditions, you are going to add hydroxides to both sides. You're going to add the same number of hydroxides as you have H pluses. You're going to simplify it down, okay, and basically rewrite your H plus and your OH minuses where you can as water molecules. You're then going to simplify and cancel out any water molecules that show up on both sides of the arrows. And basically you're going to recheck and make sure that your number of atoms as well as your charges balance.